Hi everyone. In this video we shall learn important terms in coordination compounds and their definitions. These are very important. First is coordination entity. It constitutes of central metal atom or ion bonded to a fixed number of ions or molecules. Here the central metal atom is bonded to fixed number of ions or molecules, that is ligands. That is, here the cobalt is a central metal atom. It is surrounded by 3 chloride and 3 ammonia molecules. Here you can see it is a coordination entity. It consists of a central metal atom or ion. It is surrounded by fixed number of ions or molecules. It is the coordination entity. Here we have example COCl3, NH3 thrice. It is triamine trichlorocobalt. Here the cobalt is surrounded by 3 chloride and 3 ammonia molecules. It is a coordination entity. Next is central atom or ion. Here the atom which is surrounded by number of ions or ligands in a coordination entity is called as central atom or ion. Here you can see in this ferricyanide FeCN6 3-. Here we can see Fe is a central metal atom. It is surrounded by certain number of ligands in a coordination entity. It is a coordination entity. It consists of metal atoms and ligands. Here we can see Fe is a central metal atom and it behaves like a Lewis acid. That means it accepts pair of electrons. Lewis acid is an electron pair acceptor. It accepts electron from the Cn through a coordinate bond. I have already said about coordinate bond in the earlier video. Next is ligand. The ions or molecules which can donate one or more pair of electrons to the central metal atom or ion in the coordination entity are called as ligands. Ligands can donate pair of electron to the central metal atoms. Here are the ligands. These can donate pair of electrons to the central metal atom. The ligands may be cyano or chloro. It is a coordinate bond. They donate electron pairs towards the central metal atom through the coordination bonds. They may be cyano and chloro. And the next one is coordination number. The coordination number on a metal ion in a complex can be defined as the number of ligand donor atoms to which a metal is directly bonded. Here we can see Pt is directly bonded to Cl6. Coordination number is defined as the number of ligand donor atoms to which the metal is directly bonded. Here we can see the platinum is directly bonded to Cl6. So the coordination number of the platinum here becomes 6. So PtCl6 here it becomes 6. And in the tetraamine nickel we can see here Ni is bonded to NH3 4. That means here the coordination number of the Ni is 4. Coordination number is nothing but the number of ligand donor atoms to which the metal is directly attached. Here this metal is directly attached to NH3 4 and here this metal is directly attached to Cl6. So it is coordination number 6 and in the nickel it becomes 4. Coordination sphere. A central atom or ion and the ligands attached to it are enclosed in a square bracket and is collectively termed as a coordination sphere. Here you can see FeCN6. It is present inside the square bracket. It is called as coordination sphere. The central atom and ion and the ligand attached to it are enclosed in a square bracket. They are present in the square bracket. It is called as coordination sphere. And the ions that are present outside the square bracket are called as counter ions. Here you can see it is a coordination sphere FeCN6 and the K4 here is a counter ion, that is it is present outside the bracket. They are called as counter ions. Counter ions are ionizable groups. They are present outside the square bracket. Inside the square bracket there is a central atom or ion and the ligand attached to it. They are called as coordination. They are present in the coordination sphere. But outside the coordination sphere, counter ions are present. They will not be present in the square bracket. And the coordination polyhedron. The spatial arrangement, that is the three-dimensional arrangement of a ligand atoms which are directly attached to the central atom or ion, defines a coordination polyhedron about the central atom. The spatial arrangement, that is the three-dimensional arrangement of the ligands around the central metal atom, give a definite geometry, definite 3D geometry. It is called as coordination polyhedra. You can see here CONH36 has an octahedral geometry and NiCO4 has a tetrahedral geometry. I will just show the geometry. Here it is octahedral shape and it is tetrahedral. It is square planar, trigonal bipyramidal, square pyramidal. It is the spatial arrangement of ligands. Here the central metal atom is present and the ligands are present around the central metal atom. So octahedral complex example is CONH36 and tetrahedral complex is NiCO4. These are the shapes. And finally, homoleptic complexes and heteroleptic complexes. Homoleptic complexes, complexes in which a metal is bound to only one kind of donor atoms. Here the CO is directly bonded to only one kind, that is NH3. Only one kind of ligand. It is called as homoleptic complexes. In the heteroleptic complexes, the metal is bound to more than one kind of donor groups or ligands. The donor groups are called as ligands. Complexes in which a metal is bound to more than one kind of donor groups are called as heteroleptic complexes. Here CO NH3 4Cl2. Here the CO is bonded to NH3 and Cl2. But here you can see in the homoleptic complexes only the CO is bonded to NH3. It is only bonded to one kind of donor atoms, but in the heteroleptic complexes the metal is bound to more than one kind of donor atoms. It is called as heteroleptic complexes. And this is all about the definition, some important terms and definitions of the coordination compounds. It is very important. Please subscribe to our channel. Thank you.